Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about USB Type-C complete guide. I'm going to give you everything about it. So let's dive deep into it. So what exactly is? Well, one jack to rule them all. Basically in the future, as in like by 2027, you're supposed to see this, that's it, done, go home. So that's the whole point. One cable to take care of your power, take care of your data, to take care of your media, as in displays and all that jazz. So it will be law by 2026. Now, right now, the one phase of the law is inactive in basically production right now. That is 2024 is the last year for all mobile phone manufacturers to agree to USB-C and power delivery. So Androids were agreed to USB-C long before Apple, but Apple needed to be like bitch slapped in order to comply. So they got bitch slapped, they have been complying, and they also, all of the company have to utilize one charging standard, common charging standard, which is power delivery. Without that, every company made their own BS, like a VOOC charger, Jingalala charger, fast charger, hyper fast charger. I have no idea why this name is charger, whatever have you. So all of that has to be thrown away. Now that works for mobile phone, but for laptop it needs a bit more oomph. So the law is clear till 220 watts of power draw. So 220 watts of power draw through USB-C is not sorted yet. As in, like, the rules have been made, the specification have been made, the manufacturing is going on right now. So company needs a bit more time. So by 2026 end, as in like 2027 January, you should be able to buy any laptop. Majority of laptops generally have less power draw than this. You should be just like USB-C, and you should be able to use the same cable to charge your mobile phone, or even a mobile phone charger to your laptop. And you're like, would you be able to charge it? Trickle charge it. It won't be like full and fast and all that, but at least you should be able to trickle charge it. So that's the whole point of the future, where we can have one cable, that's it, done. And over time, one cable ecosystem will happen. This will not happen day one, let that be very clear. It's going to take time. Phone, mobile phone, tablet, smartphone, whatever have you, all of them will have USB-C. However, this cable, if you really want to dive deep into it, it's complex AF. So how the heck they achieved it? Well, the biggest thing they designed is symmetry. This puppy is symmetry in 4 axes. Basically, up top and bottom is same, left and right is also same. That's how they are achieving this. That's how they are achieving. For example, let's say this top jack is your connector, and this is the board. Okay, both here I'm just flipped it. Now here's the example, pay attention. So B11, basically, that is on your board, requires a receive pin that's supposed to be in positive, and a receive pin that's supposed to be in negative. So differential pair, so receive differential. On the other side you have transmit differential, so positive and negative and positive. So B3 supposed to get transmit negative, and B2 supposed to get transmit positive. Here's the deal, you connect it one way, okay? You connect it one way, you get exact same thing. So T negative goes to B3, T positive goes to B2, R positive goes to B11, R negative goes to T10. Everything is fine. But here's the deal, what happens? You go like this, and then vajay. Then what happens? So no problem. It flips in that way. That's the whole point of symmetry. It flips in that way. You still get basically R. Your R goes to R, so R negative goes to B10, same as this one, and basically R positive goes to B11, same as this one, and your T positive goes to B2, and T negative goes to B3, same symmetry. That's the whole point. And what about power? Power is there are 4 wires, pairs, so to say. So you have 2 grounds, 2 V bus, 2 V bus, 2 ground. So that's how it can support more oomph. So that's how they achieve it. It's two-way symmetry, and total number of pin count is 24 pins. 2 pins will be generally left out, because again, D plus and D minus, they are generally used once. There is no need for doing hassle things. And again, you can pay attention, like B7 supposed to receive data negative, it will get data negative in one way. If you flip it, you still get data negative. That's the whole point, symmetry. That's how they achieved it. And that's why this cable is fundamentally far more complex than lightning cable. Lightning cable is not even 1% of this. It's like, this is like next level engineering. So this is the USB-C. In future, we're only gonna have this for majority of our appliances. So let's understand the data part of it. Universal Serial Bus. It's for data. That was the first intent of it. So there are 3 possible layers of protocols and 3 possible layers of data speeds that you have. So first is USB 2.0. Majority of USB-C cable that you deal with, especially with charger cable, generally have USB 2.0. Basically, you have data plus and data negative. Nothing else is connected. So that will supposed to give you around 40 Mbps of maximum speed. Capital B I'm talking about. So 480 small b speed. So 40 Mbps generally, like this sort of devices, more than good enough. It works. And here's the deal, for audio still works, keyboard and mouse still works. So even though we are in a world where we can have much higher speed, many things still are using this. So that's why D plus and D minus is still manufactured. Then you go one step up, that is USB 3.0. Now USB 3.0 had 2 revisions. So one revision allowed you to start with a 5 Gbps. Second revision was 10 Gbps. Now here's the deal. This was backwards compatible with type A port, the normal USB port that you think of. Type A port that was capable of doing 5 Gbps, and same amount of wiring was needed for 10 Gbps also. So they changed the frequency and encoding method to get 10 Gbps. 10 Gbps was not requiring more cables. It was just like, what if we had the cable and we used it wisely? So how the heck it physically achieved it? It utilized 2 pairs extra wiring. So D plus and D minus was always there, and then they added T transmit plus, transmit negative, and receive plus and receive negative. So there were 4 wires and 2 pairs, basically 2 positive. Differential pair works best way, because if you are having a long cable, especially let's say anything longer than 1 foot, you are talking about interference. It becomes like an antenna. So easiest way to have a long cable, let's say 1 meter, 2-meter long cable, and still transmit data at reliability, is going differential pair. Basically exactly same thing that companies do with microphones. If you look into microphone cable, it has 3 prongs. So one is ground, another is positive, another is negative. It's differential. So any interference that your cable picks up gets cancelled by the receiving device when it inverts the signal. So you do need invert of signal, like transmitting there. So T plus, T minus, R plus, R minus. So one lane is dedicated for transmitting, one lane is dedicated for receiving. So this is how you can achieve 5 Gbps and 10 Gbps. No microchips required, but do require 4 extra cables. So this is easiest layer of USB 3.0. This is majority of people's laptop and most things have. So that was the basically past. After 2022, I would say, USB 4.0 was introduced. Now this puppy introduced 20 Gbps and 40 Gbps. Now there was a hassle simply because Thunderbolt 3 was introduced by Intel as a proprietary technology. Apple went all into it. However, because of the proprietary nature and locked licensing requirements, it was not picking up as much as they were expecting. So Intel reluctantly opened the license, and Thunderbolt 3's core protocol is now USB 4. So USB 4 devices, if you have a modern USB 4 device, it should work with USB 3 devices. So that's why they needed to do a bit more redesigning. So 20 Gbps and 40 Gbps are available now, but this time you have more wires. So you have double the number of wire that was in 10 Gbps. So you have 2 pairs of TX and T minus and 2 pairs of RX and R minus. Now like, wait a minute. The port is the same. How the heck you got this? Remember, the port's supposed to be flipped. Here's the deal. What if you had 2 wires there? Again, receiving would be there, but on the socket side, basically the part of the recipient now needs more wiring, but it can be done. It's not that difficult. So again, 24 pin was put in this exact reason. That was the reason why 24 pin was there. Even though early days they were like, dude, what's the need for it? So 2 TX and 2 RX now you have. So now you have 2 lanes of receive data, 2 lanes of transmit data, fundamentally more speed. However, this sort of speed becomes stupid, meaning this sort of Thunderbolt speeds are hard to do. Even though Thunderbolt 3 is a very old technology, it's like very hard to do, and cables were super expensive. Why cables were expensive? Because it required a microcontroller inside. So you need what we call retimer chips. Basically, signal becomes very weak the moment you connect it. Now, like, why the heck it becomes it's a small thing, and it's not like a soldering connection where it's like absolute connection. It's a very sloppy connection. So you have a lot of signal interference just at the connector. Now after that, you have 1 meter or 2 meters of cable length that is picking up interference. You're having attenuation, as in signal is getting weaker. So at the other end, you cannot do proper, basically it's so jittery, signal becomes jittery that it cannot make sense. So retimer chips takes a little bit of power from the jack, reboosts the signal, cleans the signal, have a feedback loop on the other end of the cable, and then they refine the signal. That's how you can transmit 20 Gbps reliably. Now, can you have a passive 20 Gbps cable? Yes, but it will be this small. Like, do not expect, like, if somebody is selling you like something like this, 20 GPS, it may work, it may not work. But if you are selling 1 meter long cable, it has to have a retimer chip. And 40 GPS flat out will not work. Even at this length, it will not work without retimer chip. So you need to have a full computer in your basically cable ends, both ends. And yes, these are quite advanced computer. 40 GPS data integrity is like complex. Now, this is just for the data. On top of that, they USB 4 added some extra steps. That steps is optional steps that you have PCI Express tunneling. The reason is that once we reached 5 GPS, we kind of reached a stagnation point. Like, wait, what? Because here's the deal. Most people still buy mechanical hard drive for portable hard drive because it's huge. You can buy 4 terabyte, 6 terabyte for cheap. Yes, you can buy SSD, but not everybody is Linus Tech Tips. You cannot just go lol and like 8 terabyte for, flash NVMe. Yeah, that's too expensive for majority of humanity. And unless you are living in USA, all these things are very expensive in Australia, India, and basically, unless USA, everywhere else is super expensive. So 5 GPS is like more than good enough. 10 GPS, really good. That is 1 gigabytes, capital bytes. That is fast enough to do video editing. Now, 20, that's like, bro, you are reaching a speed of NVMe drive that is directly running your computer. So it is very, very fast. And here's the deal. What is the reality of accessories right now? Where majority of them are still using USB 2.0. Your mouse is 2.0. Your keyboard is 2.0. Majority of webcam, the Logitech HD webcams, they are USB 2.0. This is USB 2.0. You can have like even 32-bit float audio recorders that are still USB 2.0. So we realized very early on paper, we want more speed. Here's the deal. Are we really using it? So PCI Express tunneling was a clever way of utilizing it. So everybody knows for a fact that 99% of the time you're not going to use the full bandwidth. Okay, what else can you do? Well, what if you have PCI tunneling? So imagine a world where you have a laptop. A laptop, by the lone laws of thermodynamics and physics, you cannot cram a 4090 into it, like a proper desktop grade 4090. So what if you have a laptop, it has a portable GPU on it, everything is nice, everything is compact. When you come home, you plug this one USB-C cable to a dock. That dock has the GPU. Now you are doing PCI tunneling and that GPU is connected to your main display and you're going YOLO on it. Now, can it be worked? Yes, that was the dream of Thunderbolt and that was the dream of external GPU, but it needed a solid interface. Thunderbolt had the interface but did not have market adoption. USB solves that. So PCI Express tunneling sends the PCI packet through USB data. So your cable does not require extra chips. So it's like from cable's point of view, the microcontroller that is here, it does not care. It's like I'm getting another USB packet. It does not matter. You do need to have a cable that is supported for 20 GPS or 40. 20 or 40 cable count remains the same, but bandwidth is higher in 40 GPS. The same as like 5 to 10 jump, like basically double the frequency or improve the what we call PAM encoding. They improve the encoding. So you got more oomph out of it. Same amount of cables, but you got more oomph out of it. Now you have dynamic allocation, meaning this pipeline, that is 40 GPS pipeline that you have. Now computer can think about it. Whereas like, okay, now you have connected me to a dock. You want to run a game on basically this giant monitor. Okay, I'm going to give majority of that 40 gigabytes. Let's say it is, I'm going to dedicate 8 gigabytes just for GPU communication. CPU and GPU are talking on that. And then let's say you played the game, you stopped. Now you are dumping file. GPU is not doing much. It will reallocate. It will like, okay, GPU, go to lower data allocation. Now it will be 2 GPS and rest will be for your data transfer. So it's a dynamic allocation, so it can do that. Now, of course, not exactly as I described it, but again, this is a very complex handshake. So PCI Express tunneling allows this all things to happen. So in future, by 2027, you should be able to just have a laptop, plug a very high-end desktop grade, basically GPU, one cable. The one cable should be able to charge your laptop, should be able to directly do PCI systeming, and you should be able to just run everything on one cable. Charge your laptop, run external GPU, same cable, and you can even have like that act as a rudimentary hub, because again, what else you gonna add? Keyboard, mouse, printers, things of that nature. Those things require more than good enough for USB 2.0. So dynamic allocation will be like, I got this. So this is how PCI tunneling works. However, it is optional. It's not mandatory, meaning if you have a motherboard that has USB 4.0, the likelihood of it having PCI tunneling is almost zero. Laptops do. Many laptops do. High-end laptops do. So this is the ugly part of USB forum, where they're not locking it down. Thunderbolt, that was the good thing about Apple and Intel's integration. They were like, no, if we put the stamp of Thunderbolt, it works. There is no discussion about it. It works. It will do everything it's supposed to do, how it's supposed to do it. Meaning, neither Apple can cheap out, neither any company who's making the devices can cheap out, neither Intel can cheap out. So, consequence, it was ludicrously expensive, but benefit was it worked. USB does not have that. So you could literally have, oh, I have this GPU enclosure. It works awesome with one laptop, just does not work with another, because again, PCI tunneling may not be in another laptop. That's the penalty, but I hope by PCI USB 5 they just lock it down. So USB 4 is there, and USB 4 is backwards compatible with Thunderbolt 3. So if you have any Thunderbolt 3 devices, you can just plug it in. If you have any Thunderbolt 3 cable, most likely than not, it should work without any issue. It should work. So that's the data part of it. So you have three layers, D plus and D minus. You have RTX, one pair of TX, one pair of RX. That gives you 5 Gbps or 10 Gbps. Then you have more ICs, advanced IC, retimer ICs with 2 pairs of transmit, 2 pairs of receive, and voila, now you have 40 Gbps of speed. And you can also have dynamic allocations of bandwidth. Now you can introduce PCI Express tunneling through it. Display can also go through that. So display tunneling is also there. So this is the data layer of USB-C. So now we go to the another interesting part, power delivery layer. Now USB power delivery is independent of the data layer. Basically, the people working on the data layer, they're different. People working on power delivery, they're different. Now power delivery standard also went through a lot of revision. So it has a logical revision. Number 1, it was very good. Then they made number 2, which was stupid. Then they did 3, which was half stupid. Then they were like, okay, 3.1. That's the current and latest and greatest. Not employed yet. It will be employed by 2026. As in, like, you can buy devices, but only 1 or 2 devices exist right now. So in 1.0, they had 12 volt, but they somehow, for some stupid reason, they removed 12 volt, which is the most common voltage standard. They're like, what if we removed it? So that's why I said number 1 was logical. Number 2, they went stupid. So 5 volt, 9 volt, 15 volt, 20 volt is the standard voltage set that is available in USB 2.0. That's why people say 12 volt is not mandatory. Yeah, because in the latest edition, they removed it. It was there. In power delivery 1, whoever built it was logical. It's like, hey, what is the most common voltage adapters? 12 volt. Let's put 12 volt in power delivery. They're like, yeah, we did it. Awesome. Everybody's happy. Then they're like, what if we removed it? Yeah. So it's removed. That's why people say that USB-C power delivery 12 volt is optional. Now be mindful, most companies are wise enough. So if you're buying an adapter that's supposed to be power delivery adapter, generally they implement 12 volt. Even though it's optional, they do. Cheap ones do not. And again, power bricks, they end up with the one benefit, power bank specifically, because they do not have enough voltage to go to 15 volt or 20 volt. They're like, 12 volt is the next best. So 12 volt is still available. Majority of things will have that, but it's not mandatory. That is stupidity. So these options are available, 5 volt, 9 volt, 15 volt, 20 volt. And if you're not getting all of these 4 voltage layers, that means the power delivery device is defective, especially if it's a mains device. If it's a battery packed system, it's a different thing. But if it's a mains device, it should give you all these 4 layers. Now, how much amps you can get? That's the voltage. What about the amps? You should be able to get 3 amps. That's why I specified. It has 4 pairs of wire, basically 2 ground, 2 basically V positives. So all those wires working together should allow a proper 3 amps of delivery without any issue. But what if you want more amps? Well, there is upper limit is 5 amps, but you cannot use normal cable to draw more than 3 amps. 3 amp is upper limit. So charger will do a handshake with your device, and if the cable does not interfere in the handshake, it will be like, okay, the cable is the weak link, cable will only be locked to 3 amps. So if you want to unlock that limit, you have to put each chip there. The same as a retimer chip. It's a different chip. It does a handshake chip. And now this handshake will allow 5 amps of cable. Why is that? Well, it's a bit of safety and bit of basically to make sure that cheap Chinese manufacturers do not flood the market with cables that is rated for 5 amps but cannot do 5 amps. Now, like, can't they fake it? Well, it will cost you so much that it's like, might as well put 5 amps. So it's one of those things where it's like, they are making sure that faking it is so expensive. It's like, just make a good one, man. Just make a good one. So 5 amps. And be mindful, people do write more complaints, more things. If it's like, again, if it's not super cheap, you're not gonna throw it away. You're gonna be like, hey, give me a return on this or something like that. That's why they want that e-marker chip for 5 amps. So this is the current market right now. You can buy. You should be, if you have a good power bank, if you have a good power adapter, it should be able to give you 5, 9, 15, 20 volt without any issue. 12 volt if you are lucky, and 3 amps on any cable without too much issue if it's a quality cable. And if you have e-marker chip cables, that would be 5 amps. Generally, these cables would be rated as 100 watt cables or 120 watt rated cables. That simply means it will unlock 5 amp handshake. Now, this was till 2024. For 2026 ecosystem, they have made PD 3.1 extended power or EPR. This is not ready yet, as in ready as in like mass production. It's there, devices are available, chips are available. You can make it your own, but good luck with that. So this requires more voltage. 28 volt, again stupid voltage. Somehow they are like neglecting the most common use, 12 volt and 24 volt. 24 volt is almost the backbone of what we call power over Ethernet. Lot of devices use 24 volts. They're like, what if we do not do that? Why? So 28 volt, 36 volt, 48 volts. I like, why 48 only? Why not go higher than that? Well, here's the deal. This cable is supposed to be what we call a low voltage cable, meaning if a child chews on it, should not go up. So we have learned through hard way that under 50 volt, your skin should be able to stop electrical penetration. Meaning if you're touching a voltage that is 60 volt, does not matter DC or AC, it will penetrate you. You do not want that, because if light goes inside you, you go up. You do not want that. So 48 volt is the upper limit that we can safely, reliably count on to be safe, human safe, low voltage. So if you have higher voltage, then it will be rated as mains voltage, meaning you have to treat it as a live wire. So it becomes exponentially expensive to deal with. So 48 volt it is. 5 amps, same amp is the same thing, because why didn't they make it thicker? Well, some companies did try, Oppo, Vivo, they did had 6 amps and 7 amps system, but the cables were way too thick and way too expensive to implement. So they're like, okay, 5 amps, 48 volts and all that jazz. But be mindful, this PD 3.1 requires special chip. If you have an e-marker chip, you're like, okay, I have an e-marker chip, I should be able to draw 5 amps at 28 volt. You cannot. Now, why is that? Well, as the higher the voltage, it does come with a penalty of arcing. When you plug it in, it's not like a ka-chung. It's not like, circuit breaker kind of plug. It's a very sloppy button. So this sloppy nature causes a lot of arcing damage, especially at 48 volts. So if it's not done correctly, it will cause melting, damaging, fires, things of that nature. So they created a same standard. You have to have such an expensive chip into it that it will not make sense for you to like just somehow buy a super expensive chip and put a crappy cable on it. It will not make sense, economically speaking. So it will be like, okay, now you need a external which is supposed to have higher gold content, like so it can withstand the corrosive effect of that arcing and all that jazz. So 28 volt, 36 volt and 48 volt. Only one laptop I know that uses 36 volt yet, and 48 nothing has joined in yet. That is Frameworks 16-inch laptop uses 36 volt. And the idea is that in principle, in future, even if you have a laptop and you close it and you just plug it in your mobile charger, which could be, let's say, 20 volt only, it should be able to trickle charge your system, because we have very advanced buck boost converter nowadays. So you can easily boost, because again, that laptop that I'm talking does not have 36 volt laptop battery. So 36 volt is not present. It's down converting it. So 36 volt is there, 48 same. And again, all of this is happening simply because they want to lock the amp requirement, 5 amps. So this is how it's going to require special chip, special cable to unlock this EPR, extended power range. Normal cable should be able to give you 60 watts of power without any issue. 5 amp cable should give you 100 watts of power without any issue. That should be there. And I have no idea how the heck somebody came up with the amazing idea of let's put 12 volt, which is the most common wall voltage, to throw it away in 2.0. And then somebody's like, what if we made 28 volt? I'm like, 24 volts. But it is what it is. It is what it is. So this is the power delivery, and that's the whole point of it. It's not just focusing on mobiles and laptops. It's also focusing on power drills, monitors, e-rickshaws, e-things. Basically, anything that is under 200 watts should not require its custom hula-la-la basically anymore. So that's the power delivery. That should be by law in 2026. Now, these are the two primary objective of USB-C. There is a third objective, which is alternative mode, or alt mode as they call it. Now, the idea is that if you take a USB-C cord, the cable, it has a lot of wires inside. It could have like a lot of ground wire and V plus and ground. Okay, let's not touch it. That's power wire. It has data positive, data negative. Okay, let's not touch it. You still have basically transmit pairs of wire and receive pairs of wire. That's good. And then if you have 20 GPS, you have 2 transmit 2 lanes and 2 receive lanes. So that's a lot of wires inside. You are looking at upwards of 22 wires. So that's a lot of wire. So it's possible to split them into groups, meaning you can have one cable and this cable can do things. What sort of things? It can be basically USB 3 data transmission. It can be USB power delivery, and it can be a DisplayPort also, meaning it can take care of, you can connect it to a hub. That hub can basically be like your access point where you can dump media into it. It will work at very high speed, USB 3.0 speed. So you're going to get at least 500 Mbps or maybe even 1 Gbps speed. 10 Gbps option is available. And while you are connecting a monitor, so your mobile phone, you dock, now you have a keyboard, mouse and high speed peripherals, and you can connect the monitor and you can charge your phone, same cable. Alternative mode. Now be mindful, this alternative mode is the biggest problem. This is also optional, so it's not implemented in everything, but if it's done, you can give data, charging, display, all of them would be possible. However, this is not inside USB-C, this is outside USB-C. This is like somebody is like, hey, USB-C cable is awesome. What if I hijack that cable? So to hijack that cable, we utilize USB-C MUX chip. So normally USB will go through normal MUX chip and that's it, done. USB to USB port, but MUX chip comes in between. Basically USB to USB port, it comes in between. So it's like, hey, USB data, go YOLO. It's like, but somebody sends a signal, hey bro, I want a display out of it, then it will directly connect the GPU element of it. Now again, be mindful how many GPU elements it uses. Does it use onboard graphics or a dedicated GPU in laptops? That's up to the manufacturer. In case of your smartphones, especially flagship phones, most of them directly connected to the GPU. So you can get out of it and you will not get, and if it's done correctly, you have 4 lanes of display output, lanes as in like TX, RX, if it has 4 of them, it will give you uncompressed, very good quality 4K low latency. Because again, from electronics point of view, there is no conversion, there is nothing happening, just data comes in, data goes out, nothing. MUX chip is just a switch where it's like nothing else is happening. It's not a logic converter where it's like all it's doing is switching. So all it has to do is handshake, and again, power delivery is completely independent of it. So USB 2, it will never touch, power delivery, it will never touch, and you have display. Now here it can select from 1 lane to 2 lane to 4 lane. That's why this function of USB HDMI output was available in USB 2.0 days. So that's the whole point. You can have 1 lane, 2 lane, 3 lane, 4 lane. That's up to you. Up to you as in like the manufacturer. So all of those things will be available. It's an optional feature set, but when it has, it works awesome. So you can have custom cards like this where you have USB-C and HDMI output of it or DisplayPort out of it. How the heck it's working? That's the whole point. It's just giving a signal to the MUX chip. It's like, bro, switch to GPU. So Samsung's S series phones, all of them have this MUX chip. All laptops that can have USB-C video output has this MUX chip. So it's a very good thing. Apple also has this MUX chip. So it was a very clever implementation. It's like we have so many cables. We are not using all of the cables. What if we use all of the cables? So you have data, power, and display going through the same thing. HDMI, DisplayPort, these are the 2 primary protocols. Sometimes you can also send through Thunderbolt. So that's how it basically, if Thunderbolt implementation requires a dedicated pipeline, its MUX chip is like, I got you. So you can have 1 chip that is for basically USB, 1 chip for Thunderbolt. And if it's a really complex computer, it could be like 1 for GPU also. Why would you need Thunderbolt and GPU output? That's up to you. But if you need it, it can be done. The MUX chips are available that can do 3-level switching. So this is the alt mode. So it's basically utilizing the 22 wires inside. It's like, hey, you don't need all 22. Most of the things can be done in very few pairs of cable. So what if we use other pairs wisely? So in future, you can just have a TV that has a USB-C cable coming out of it. You just plug it into your mobile phone. Voila, it just works. It's just like your mobile phone is charging and you have a very low latency. Because here's the deal, you can, if you have a very cheap Android phone, you can still get the same thing. There are some Chinese options that are Google Chromecast over USB 2.0, but it does have low latency compared to the wireless implementation, but it's very compressed and it is still laggy. But when you have MUX chip, it's like, because again, from electronics point of view, there is no conversion, no compression. That's just like data out, done. So this is the alt mode. It does require a different chip and does require inputs and output, but it's awesome. Now we come to DIY also, because USB, we have a lot of power watts, basically your routers to your old consoles, heck, even my oscilloscope, or everything nowadays has a power brick. So idea is we do not like it. And again, that law is awesome that by 2026, majority of things will flat out by law will be basically USB-C, but it will still take time to replace our old devices. But what if your old device is working? So DIY options have cropped up a lot. So you can buy what we call USB-C dongles, decoy boards, and decoy boards, generally very cheap ones, will come with fixed voltage. So for example, if you are talking about devices that are 9 volt, just buy USB-C decoy 9 volt. And the moment you collect it into any power bank that is power delivery activated, any adapter that is 9 volt, any power delivery adapter, it will just give you 9 volt output of it. Same with 12 volts, same with 15 volts, same with 20 volt. You do not have to do anything else. So basically, instead of having very cheap Chinese quality wall warts, which is the biggest reason why people are doing this, is like those cheap wall warts, they are very cheap. If you buy that quality wall warts, it's not just limited to one device. You're like, hey, I'm using this for, let's say I'm running my retro console on USB-C. Then it's like I'm traveling somewhere. Okay, I'm going to use the same USB to charge other things. So that can be done. That's why people want this sort of ecosystem. Less e-waste, one thing to rule them all. That can be done. So you have a lot of options of doing so. Decoy buoys are available. These are cheap ones that will come with fixed voltage. You have a reprogrammables one where you can just press one button. Bit more expensive. And then you have this one. I just bought it recently, experimented with it, where you have switches and you can set the voltage to basically 5 volt, 9 volt, 12 volt, 15 volt, and 20 volts. So these are available. And that's this is on the basically receive side. Some people have went all in and they modified their laptops. Especially cheap laptops have enough empty space that people can directly embed this board into the basically laptop itself. Of course, you will not get data out of it, but again, this is very cheap implementation. It can be done, but it's like the board will become expensive. So they do it. Now they have a laptop that is USB-C. Mobile phones are already at USB-C and many laptops do not consume 200 watts. So more than enough system can run on this sort of requirement, especially not super high power ones. So you can just go YOLO on it. And again, for many other people, they are buying things like this. If voltage and current matches properly, then you can just buy this adapter and you do not even have to modify your laptop. You just plug it in. It works for low power devices. Again, 100 watt rated. Be mindful, it assumes that you have a e-marker chip cable, because otherwise it will be limited to 60 watt. Again, there are more than enough laptop that works in 60 watt, but you have to be mindful of that. So that's just on the receiving end. But what if you want to transmit it? So for example, this is my brother's first laptop's power brick, a Sony Vaio. Yeah, it is ancient, 15 years old. But unfortunately, the voltage is not very high, 19.5 volts. But if you have this sort of power bricks or wall warts, you can utilize a chip like this, where you can convert this brick into a USB-C power delivery device. Now this can charge my smartphone, fast charging and all that. Depending on how much money you want to get, you can get some fancy setup where it can have 4 or 5 ports, and some setups have this one is a buck system, meaning it's only can bring voltage down. So you're supposed to give a very high voltage power system. In my case, I can utilize still 15 volt without any issue. Higher than that, it's like bro, I am only receiving 19.1. The stage will reduce some voltage, so 18 volt gets out. If your device requests 20 volt, 18 volt will go out. So that's the weak link of this. Again, many of the devices, they do say it's buck and boost, but I have not noticed it. So I would recommend that if you're buying this sort of system, please have a high voltage system. 24 volt is minimum if you want all the voltage rail. Or if you have a fixed use case, for example, a majority of mobile phone do not cross 15 volts, you're like, okay, more than good enough. So that's one way of reducing e-waste and utilizing your old devices, especially if it's a high power one. Because again, this puppy is 19 volts, almost 3.9 amps. That's a lot of power. That's like, again, the main point is quality of this device. Again, I can buy a cheap Chinese system, but I will not trust them. This, the signal to noise ratio, all the jazz, and reliability, surge protection, all those jazz. That's why, again, it's working after 15 years. Good stuff. So you can do a lot of things. And power pack wise, again, there are people who are making power packs directly themselves, because again, in terms of power bank, it's not there yet. We are not there yet. You can buy it, but they are very expensive. They are not mass produced yet. It will take some time. So this was my presentation on USB-C everything, the alt mode, the DIY route, the data route, the the power delivery route. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.